Yes, hello and a very warm welcome to my channel. Greetings to all subscribers and everyone who hasn't visited my channel yet. You're also very welcome, of course, and remember, if you don't want to miss any videos, then subscribe. Yes, today we're starting with the Andeli MIG 270 TPL. I've spent a bit of time looking into it now. Today we're looking at the TIG welding process, specifically the cold process that the machine does. So what that really means is that cold allows us to join together very thin pieces of material, especially in situations where you simply can't apply too much heat or keep the heat on for too long, because that could damage the material. And what I've discovered through my own experience and the process I went through to figure it all out, that's exactly what I want to take the time to show you here today. Yes, but before we get started, I want to show you something else. And for that, we'll look at the back of the machine, at the gas connection. They've installed something there that's quite interesting, a clever idea, and I'd like to show that to you. Yes, the machine was delivered with a part like this. This part is nothing more than a pneumatic hose connector, and I think the idea itself is quite good. They've simply pre-mounted a piece of this gas hose here with a hose clamp. And then they've attached the pneumatic connector, and now I just go ahead and take my gas hose, plug it in, and when I'm finished, I naturally close the cylinder first. Press this blue button here and I can pull my hose off. Cool idea, works perfectly. But there's something to consider. Now I have another spot here where leaks can occur, so you always have to, let's say, maintain it properly. And also check that you're not losing gas somewhere. If you were to go ahead and forget to screw the cylinder shut, and the system isn't entirely tight, then it's really annoying if a whole tank of gas is suddenly gone overnight. So you have to be careful there, of course. And always remember to close the cylinder. That's the key if you want to get the most out of your gas. Okay, I just wanted to show you that. I've seen it with other manufacturers too, but I think the idea itself is great. Someone had a clever idea and I always like that. Well, I have the included hose package in my hand right now. I also have the power cable here with me, which, as you probably know, always needs to be connected to the negative terminal when you're doing TIG welding. If you don't do this and instead connect the cable from the hose package to the positive terminal, the tungsten electrode will burn off very quickly, which is definitely something you want to avoid. So always make sure you're connecting it correctly for TIG welding. So then we have the gas supply line. So the gas line is now plugged in here at the front. It's not like with other devices where the gas is basically routed separately. No, it runs through the machine here because it's being controlled now. That means when I press, the gas should flow, and when I let go, it should stop, of course. That's the reason. So then we have the control line here that regulates everything, which then tells the machine on or off, because that's all it is. And then, of course, I still have to mount my ground clamp to the positive terminal. And just like that, I've mounted my TIG hose package. So now we have here the TIG needle inside, and it's flush, so maybe just a hair behind the end of the ceramic nozzle. That's how far I've pulled it back, and you have to do that so that you can also weld in the cold process. At least that's how I did it. Maybe there are some pros who can give me other tips, but I've done it this way now, and honestly, I think I've managed it quite well. Good, that's it for the TIG torch. The gas is clear, and for the argon, you can use either 4.6 or 4.8, whichever you have on hand. Like I said before, the cold process is just for thin sheets. Yeah, when you join two thin sheets together, in the past you always had the problem of quickly burning through something. And here you have a short pulse over a certain time with a certain current intensity. And yeah, then you basically join the sheet metal. Well, now I've switched the machine on. I'm still on the MIG-MAG process here, but I don't want to be there. I want to go to the TIG process, but not just the TIG process, I want the cold process. So now I'm in the cold process. In the cold process, I can now set my current intensity. In this case, I have 60 amps here, but I could also go and set 200 amps, depending on what I want to do. And yeah, but I want to have the 60 And I'll go ahead and use this button right now to configure the interval. That means whenever the pulse comes, tick, 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 for example, at 10 or at 1, 1, 2, 3, so a bit slower, or at 0, then a pulse comes every time I press. So I press, pop, there it is. I look at my tack weld and do the next one. That's how the principle works. In the next point, I can set the times for how long my current intensity, the arc, stays on. That's 150 milliseconds now. The maximum is 200 milliseconds. That's basically the basic principle. And now let's take a look at the practical part to see how it looks. Now I'll set the pulse count to 0. 0 means there's no further pulse, there's only one pulse when pressed and nothing else. So when I press now, bam, the pulse comes, but only ever when I press. This is an ideal method if you want to tack and don't want to apply current for too long. And now this way too, so you can see how I press the button. Now I'll set the interval to 3, and then of course we should get 3 pulses in quick succession. Take a look. Bam, bam, bam. Yes, it works. So, just for fun, let's turn it up to 10. And then let's see how it pulses. And we see that's obviously extremely more. These are all the things that have to be adjusted later during welding. Now I've clamped a sheet of metal, I've set the interval to 10. And now let's see how that works. Oh, I can tell already, I think that's too much. It's quite hot. I probably should have chosen just a little bit less, you know? Yeah, but, well, bam. Hole in it? Well, that's not the right setting. Yeah. And now again, no. Let's turn it down a bit to 6 intervals and then see how it works then. Yeah, that definitely seems a lot better already. I can really notice the difference. It's not quite as hot in here now, which is a relief. Yeah, it actually works really well like that, I have to say. Yeah, that's just the point where you have to adjust things first. The good thing about this machine is that once you've found a setting, you can save it. And then you don't have to search for everything again. But it works quite well like this. If I had a glass attachment now, I wouldn't have to hold the torch at such an angle. Then I could see exactly where the tungsten needle is in the middle of the seam. And then it would be even easier. But it works quite well like this too. Now, no, that's wonderful. This is fun now. It's not that difficult either. Well, then we'll take a look at the seam later to see how it looks now. So you can still try a bit more now. Maybe we can use a bit more current or something. Those are the subtleties you have to find out first. Test them. It can be a bit different from material to material again. But I'm really satisfied. It works wonderfully for the thin material. So that's what the result looks like now. At the beginning, you see I chose the interval a bit too short or too long. It was too fast in succession, too much energy. And then I had a hole in it in no time. Then I turned the interval down and lo and behold. Then it suddenly works wonderfully. You can see a very nice root here at the beginning. But there I was simply too strong with the pulse or with the current. I could have adjusted it more finely. Well, then the sheet metal warped a bit. I should have maybe tacked it there again. But there we can actually see the root quite nicely. The root comes out nicely, so it works really well with this process. I am, yeah, actually really thrilled. Nice. So I made another sheet metal. That's a slightly different setting. That works much better already. Honestly, I have to say, the first section here of this seam was really fantastic. It really turned out great, and you can see the improvement even just in this part. So that looks really good already. After that, I interrupted, tried another setting, but that didn't work so well. But you can see that in a moment on the weld seam. But as I said, it's a matter of settings. And when you've set it well, here you see, there it's good. And the second one where I then started, there it was. Then not so good anymore. Yes, a matter of settings. And if you set it up well, you can get it done wonderfully. Yes, and we're already at the end again. And I hope I could show you something here today. Hope you liked it. Leave a sub, thumbs up, and then take care. Until next time, bye.